All right, in this video, we're going to do some more graphing, but we're going to be looking at graphing variations of sine and cosine. Okay, so I want to start by having you consider this form right here. Let me explain once I get it written. Okay. So the basic function is just y equals sine x, but the letters A, B, C, and D are parameters that are going to affect what the graph looks like. Okay, and what I say here for sine also would be true for cosine. So this covers both of them. Okay, so that letter that you see out in front that's being multiplied by the sine of bx minus c, that right there, the A, has to do with how stretched vertically the graph looks. That's called the amplitude. Okay. So it's like actually what it is the distance between the x-axis and the highest point, or the x-axis and the lowest point. So that's the amplitude. Okay. Now, if the A value is bigger than 0, then it'll be in its typical orientation, just like the regular graph of y equals sine x. But if the A is less than 0, which means the A is a negative number, then it will be reflected across the x-axis. Okay, and you kind of remember how that works. If you thought about back with y equals x squared, how that opens up, but if you had y equals negative x squared, how that opens down. It's that same concept. Okay, so the A can do two things. It can stretch, can make, like if this were your regular graph, if the amplitude is a bigger number, then the graph is going to possibly stretch higher and lower, like so. And we'll kind of see how that works in just a minute. And then if the A is bigger than 0, it'll be in its usual orientation. If it's less than 0, then it's going to flip and be on the other side of the x-axis. Okay. All right, so let's just deal with that right now. So if we have y equals 1/2 cosine x, let's think about what to do with that. All right, so it still helps, I think. Here, let me go ahead and do this down on the graph paper itself. So y equals 1/2 cosine x. So before we do that, remember the unit circle and those 5 key points that were so helpful. Okay, still good to remember those and get those accurately labeled, these 4 key points. Okay. And then if we're going to try to graph y equals 1/2 cosine x, I just want to remind you that if we did cosine x, what helps is to use these 5 points, go around, and then use this for 0 and also for 2 pi. So look at when x is 0, look at when x is pi over 2, look at when it's pi, 3 pi over 2, or 2 pi. Those 5 key points, and then all we have to do is extend the graph to the right and to the left. And remember, for cosine, the value of cosine comes from the x-coordinate of that point. So when you're at 0, it's 1. Pi over 2, the cosine is 0. At pi, cosine is -1. Back at 0 for 3 pi over 2, and then 2 pi is going to be back at 1. And so we can get the graph of cosine graphed pretty quickly. We can extend that pattern, because this is a periodic function, and we can wind up getting a pretty nice picture, okay, in both directions. Okay, something like that. All right, so what you see in black right now was y equals cosine x. All right, now if we're trying to do 1/2 cosine x, see how you would already have plugged in the 0 for x and done cosine of that and gotten the 1. So 1/2 out in front just takes each of those outputs and cuts them in half. Take 1/2 of each of those. What effect that has on the graph is your graph is going to be flattened a little bit, okay? It's going to go like that. Every y value is going to be half what it used to be. 0 will still be 0, but then all the others are going to be just half as high up or as low down as they used to be. See that? Okay. And so what you see in red is the gist of the graph for y equals 1/2 cosine x. So the 1/2 affects vertically how far your graph is stretched from the x-axis. So here's the way I think about it. I think is really helpful. These spots right here, these x-intercepts, they're like nails. Okay, so this is like a rubber band. These are like nails. Okay, so they don't move. But then for y equal 1/2 x, your rubber band would allow your highest and lowest to be closer to the x-axis. If you had y equals cosine x, it would be stretched a little more. So it's a little further away. You would pull on these high and low points to pull it further away from the x-axis, okay? All right, so let's do another one on top of this. I'm going to do it in blue. So what if I had y equals, let me do it in blue. So let's look at y equals -3 cosine x, and let's think about what happens there. You could do it just by, plotting points like we did before, okay? You already know what happened for those 5 key points for the cosine graph, and then you could just multiply each of those by -3. So what you used to have, the 1, let me go ahead and put it back in here. So we had these values. So we could just go in if we wanted to and get the overall outputs by multiplying the 1 by -3, the 0 by -3, the -1 by -3, and so on, okay? And then we could come over to the graph and just plot that x with the corresponding y and see what happens, okay? So we could do that. So 0, -3 would be here. Then we'd have 0, 0. Okay. Then we'd have pi at +3. And then we'd be at 0, 0 again. And then 2 pi would be back at -3. So you kind of see where it is. It would look like this. Okay. See how it's been stretched further away from the x-axis? That should be curved, not like a V. Okay, and then it would go back in here. This would now be way up here again at +3. So I just follow that pattern. Okay. And there would be my new cosine graph, which you see in blue. Okay. So when you're looking at that one, A was -3. Because A was less than 0, because it was negative, that's why it flipped across the x-axis. You see that? And then the absolute value of A is 3. So that's what's telling you its amplitude. See how it's 3 units between the x-axis and the highest point, or 3 units between the x-axis and the lowest point? That is the amplitude. Okay. All right. So a lot of times when I'm trying to graph that right there, I kind of just go through a sequence in my mind. So let me show you what sometimes works good. If I'm trying to graph -3 cosine x, okay, what I sometimes start with is what cosine looks like. Okay, so I know it's going to follow that pattern. Okay, so I get my cosine on there. That's my basic function. Okay, so first I'm thinking y equals cosine x. Then I'm thinking y equals 3 cosine x. Okay, so then next I might do 3 cosine x. Let me do that in red. Okay, so that's going to make me stretch. These are like nails. And then I'm going to pull the graph away from the x-axis until it stretches all the way up to 3 and all the way down to -3. Okay, so I'll kind of go through in my mind a progression when I do it. Okay, and then finally, the last thing I do is I think, okay, so the negative out in front just takes that picture that I just did and it's going to flip it across the x-axis. So this is going to be down here. This is going to be up here. Okay, so it's just going to go like so. So you can use the 5 key points together with the gist of what you know should be happening to do a pretty quick sketch. Okay, and this is my final answer. All right, so that looks at what A does, and it has a similar effect if it were sine instead of cosine. It would be the same idea, okay? All right, now let me get some space in here because I want to talk a little bit about what the D does. Okay, so let's look at that. So remember the general form. Okay, these are the parameters. Last time I talked about what the A did. What I want to do is mention what D does. D is a vertical shift. Shift up and down of the whole entire graph. Okay? All right, so if the D value is bigger than 0, that means it's positive. Then you're going to move the whole thing up D units. Okay? And if the D is less than 0, which means the D is a negative number, that's going to shift the whole graph down however many units D is. Okay? All right, so let's think about that. Let's suppose we're trying to graph, we'll graph y equals 2 sine x, and then have this little -1 sitting there. Okay, so we got both an A and a C value in there. Okay, so I'm going to do that here. This is y equals 2 sine x minus 1. Okay. All right, so what you would think about here is the 5 key spots. Always nice to have those labeled correctly and in mind. Okay. Okay, there they are. And then you might just start with the basic sine graph and go around to those areas. 3 pi over 2 and then 2 pi. All right, and sine, remember, is the y-coordinate. So this time I'm looking at the y-coordinate around the circle. And what happens is sine starts right there at the origin, where cosine starts up at 1. And then it goes up, back to the origin, down to -1, back to the origin. Back to the x-axis and then up again. Okay. All right, so this is the basic sine graph. Looks like cosine, but it's just been shifted. Same feel. It's just shifted a little bit. It starts at 0 rather than starting at 1. Okay, so if I were going to do this, one thing I could do is go ahead and just modify things. Look at next, maybe look at the 2 sine x, which means you take all of your original sine values and you multiply them by 2. So the zeros stay 0. This becomes +2, this becomes -2. 2 is the amplitude, right? So 2 is the amplitude. So every point is going to be 2 times further away from the x-axis. So these don't go anywhere because 2 times 0 is still 0. But then this point should be double This point should be twice as far as it used to be, okay? And so I just draw it with it being stretched vertically. So every point is twice as far from the x-axis. Okay, so I have that look. So the original one was y equals sine x. The red one is y equals 2 sine x with an amplitude of 2. Now, what the minus 1 is, that is a vertical shift of the whole entire red graph. So like after you've done all that, you would come in and the next thing you would do is take those values and subtract 1 from all of them. So instead of a 0, that would be a negative 1. Instead of 2, that would be 1. 0 would be negative 1. Negative 2 take away 1 would be negative 3. 0 take away 1 would be negative 1. And so then you'd compare, you'd be using these ordered pairs, this x value with this y value, okay? But it helps to kind of know what it's really doing so you get a sense of it. So see, 0 would now be down at negative 1. Okay, when you're at pi over 2, rather than being up here at 2, you're going to be down 1 unit. Okay, then at pi, rather than being here at 0, you're going to be down at negative 1. And then here, rather than being at negative 2, you're going to be down at negative 3. Okay. Here you're going to be down 1 unit. Here you're going to be down 1 unit. So it's kind of fun to think about it in terms of a shift. Okay, this would be down 1 unit. See, it doesn't stretch. These don't stay put. They actually move down 1 unit. So every y value gets moved down 1 unit. But it's just like the whole thing's been slid down from the red that you saw before. Okay. So then you would have this picture. And that would be your final answer. This would be y equals 2 sine x minus 1 after the fact. Okay. So doing a progression of graphs, I think, can be really helpful. Or you can really work hard on these 5 key points to help you get things where they need to be. Okay. And this, again, works in a similar way, whether it's sine or cosine. It's just